afternoon, good dawn, good whatever it is, wherever you find yourself on the continent. This is IoT Tuesday, your one and only show that demystifies IoT, applies it to real life situations, and demystifies all the myths that you might have or think you have on IoT. When we come back, I will be talking to you in today's episode on cloud to device communication. Stay tuned. Awesome. Welcome back. If you're joining us, this is IoT Tuesday. Welcome. I am yours truly, Samuel Adrani. In today's episode, so a couple of weeks we started series on building a home environmental monitoring system, and we started with connecting sensors all around. We moved on to protocols, communication protocols in IoT, and then in couple of weeks, I think 2 weeks now, I have been talking about how I built my COVID-19 system that allows you to hands-free or touchlessly wash your hands with soap water and get some paper towel dispensed. Now, as you always know, before I get into it, there are a couple of things I want to talk about, get that out of the way, and then we can get started. Now, first of all, please, 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 do not have the fear of sharing late, what I term FOSL, or fear of posting late, or FOPL, and just share anything you get on social media now or even in the future. We are already in trying times, and there's a lot of instability, uncertainty, and a lot of fear in the atmosphere around us. That don't think that if you don't post something, someone else is going to post it before you do, and therefore anything you get your hands on, whether validated, whether true, whether false, whether it just post it. No, people, pause. When you receive something, pause, assess it. If you think it's above your understanding, reach out to professionals who are in your networks. Ask them about it. Seek some clarification before you go posting stuff. One thing that has been making a lot of social media, I don't know how to put it, is the fact that COVID-19 is something that has to do with 5G networks, IoT, and gosh, please, please, let's discern. I'm not here to talk about that on the show, but all I want us to learn is that anytime you get your hands on any information, be it Facebook, WhatsApp, any form of social media, before you are in a hurry to share it, validate it. Don't have the fear of sharing late or posting late. Validate it before you send. See, trust me, some of these informations and things you're passing is enough to even kill people who even don't have the COVID virus. So please, let's descend. Okay, let's be discerning and know how to post and what to post and when to post it. All right. With that out of the way, I want to say welcome to you all joining on different streams. A big thank you to Ishmael Lamte for making what I'm about to show you possible. So next on the list, I want to talk to you about the build. So 2 weeks ago, I showed to you a system I was building that allows you to touchlessly wash your hands, get soap, get water, and then it didn't have the paper dispensing side of it. So I spent a couple of days to add that to it, and then this is where we are. So I'm going to be sharing that with you. So let's go here.
So
Just watch
this
this.
whole rig is supposed to be a self-sustaining system.
So take a look.
So this whole rig is supposed to be a self-sustaining system. We're using this 150 watt solar panel to power. Yes, you might say this is huge. Yes, it is huge. But the idea is that we are going to probably power some smart bins and other things around it. So this whole rig is powered from this solar panel here. So cool. Yeah, to turn it on, first of all, let's talk about the components. So this is the soap. We have a pump, a hose for the soap. As you can see, we fitted it. This is where the water is. This is just, so you just fill this with water. Ideally, this would be recyclable, and then that is the waste. But this you can probably put in the gutter or in the drains or something like that. So to make it, to start using it, You just have to turn it on with here. There you go. Now the green light, so it has both audio and visual feedback. So the green state tells you that it is ready to be used. Anytime it's in use, the pump is working, it's going to turn red. And then there's also a little buzzer and alarm that beeps to tell you the state of it. So I'm going to walk you through how this works. So I know I have to do proper labeling. So the first side here is the soap, and this one is the water. So as you come, as simple as that, I put my hand here, and as you can see, the soap drips. There you go. I can just, apply the soap on my hands, and then I come to the water, and then this is water. Forgive me, I'm not using the same, the approved way of washing hands yet. I'm just trying to demonstrate this. So this is programmed to run for, I think, 15 to 20 seconds. I can update this if I want to. So with this, shake off the water a bit, and I just wave here. And as you can see, my paper comes. I just stir this, and then off I go. I can, just stir this if I want to. That's it. Wash my, clean my hands very well. And then the idea was to have this bin also smart. So right now that I finished this, I would have just waved my leg here, or just waved my hand here, and then the bin will open and I'll drop this in. But we're waiting for a bigger torque servo motor to lift this up. So that's how the system works.
Awesome. So that is how the system works. As you can see, this is how far we've come. And I like to emphasize on a few things. This is a prototype. I have received a lot of comments that the rig looks, unpolished and all. I was like, yes, this is a prototype to ascertain, the whole functionality. We are actively working on a housing or a casing for it. We can go with, it could be just full boards like plywood or MDF. It could be a barrel. It could be whatever it is. We're looking at the very optimum way, make it lightweight, easy to move around, and mobile. Thank you, Lady Lightly. Thank you. And welcome to the show. I mean, obviously, so I have made the sketch. I actually published the source code to this and the sketch on LinkedIn and Hackster.io. Actually, let's see if I can just let me pull this out here. So let me bring the browser here. Let's go in here so you can see this. So I made it public yesterday. So for all of you that want to see how I did it, the source code is there right here on LinkedIn. Let me post the link here so you can go check it out. And then, so the whole code is here. And then if you go to hackstar.io, on hackstar.io, I actually have the whole project here. So as you can see, images of the project, the bill of materials, everything there, the story, and then the cool thing is I have all the videos, the previous one that I posted, the new one, and then the schematic is here. I want to actually go, let's see if I can open this up. So I'm going to open the schematic, explain a few things, explain the code as well, and then we're going to move on to today's main topic. All right. So if you have any questions, you can post it. I will try to answer that for you. So let's go into. Let me open the schematics so that I can share. Ba, ba, ba. Yep. So here we are. So this is the schematic for the system that I have. If you go to the link I posted on, let me know if you actually got the link I sent for GitHub. If you can see it, because I don't know, I have posted it but I can't see that. Let's see if um, I can send it here on Twitch. Okay, yeah, there you go. Yep. So let me try this again. Yeah, all right. So I just posted the GitHub link to the project. You can have access to it and go play around with it. So let's let me zoom in a bit. So there's the schematic for it. Let me bring it a bit in view so it's easy for us to see. Um, so yeah, quick one. If you're, I don't know, the pump you're seeing, the two pumps The parts are not available on Fritzing. I had to design this in CorelDRAW and export it as component here that I used in Fritzing. So if anyone needs any of these things as a component, I think I should just put that in my GitHub repo, share for people to use that. Yeah, so if you were following me, you would have realized that initially I was using an IR sensor for the sensing, but because it doesn't play too well in daylight, I needed to probably be covering or enclosing it. I decided to go with the ultrasonic sensors. So we have three ultrasonic sensors, one for the soap, one for the water, and one for the paper. So that's how I'm doing the dispensing. I talked about the MOSFET I'm using. These are acting like relays that are controlling the pumps, the soap and the water pump. That's it. We're using an Arduino as a brain, and then this is the buzzer or piezo. That is what beeps beep beep. That's what does that. And then we have an RGB LED. So as of now, I'm just using the red and the green, so I didn't connect the blue because I didn't have use for it. I could use it if I wanted to, but that's just it. And then so I'm using a regular DC uh, I think water pump, and then I'm using a diaphragm, a mini diaphragm 12-volt pump as well here to pump the water. Now, and then the servo, this is a continuous rotating servo. That is what I use to, the mechanism that is dispensing the paper. That's it. And yeah, a couple of things. When you saw in the video, I'm going to make a small modification to the paper tearing mechanism. I want to that bar you saw there is just to hold the paper so that the wind doesn't blow it over, like the paper doesn't keep rolling. But I'm going to extend it and then add some teeth to it so it's easy for you to pull up and just stir the paper. So that's something else. So this servo is the one that's controlling it. Now the two pieces here. This is a buck converter. All right. So now I have two of them, and that is because I would explain this. The pumps are 12 volt, but the solar panel gives off in excess of 20 something volts that comes in. So I'm using the buck converter to limit or reduce or convert that 20 something volt into 12 clean 12 volt that is used by the two pumps. So that's why you have one buck converter here. Now, the servo also uses 6 volt and not 12 volt. If it was a 12 volt servo, I would have gone straight with this power source. But because it was 6 volt and I was getting over 20 volt from the solar panel, I needed to also, step this down to clean 6 volt for the servo motor. So all of them are picking from the same power source, but then they have two buck converters that are reducing the power for it. Yeah, I'm being technical because this is an IoT show. I want to demystify it. In terms of the wiring diagram, just follow the stuff here, and then quite simple. So that's how we did it. Now let me talk about the code. Let me see if I can open my Arduino. Yeah, let's open COVID hands-free. I think that's where all the code base is. I'll share that. And hey, if you have any questions, please feel free. Ask me about it. And then if there's any suggestions and things you want to see. Oh, by the way, a big thanks to my Yabwe brothers, Fifi Coleman, Derek Sowonu, Junior Edmond Singh, um, Emmanuel Abankwa, and the list goes on. And Nitete, yes, good idea from Nitete. So because currently we don't have any mechanism to recycle the water as we plan to, we're thinking that it will be a good way to actually channel the waste, the waste that gray water, or we call it gray water, that gray water into, let's say, a toilet flushing system, so that water can be used to flush the toilet and doesn't go to waste. So the whole system is self-sustaining. So as always, I'm using the servo library. That is what allows me to control things like this servo. This is an SG90 0 to 180. So there you go. So this like this and all the continuous servo. This is the Arduino library um, that is used to control them. Now the ultrasonic sensors, as you see them here, have 4 pins. So there is the power, the trigger, the echo, and the ground. So the trigger is what sends that sonic signal, and then it's a wait for it to bounce off any object in front of it, and then that returns, and then the echo is what tries to the echo captures that signal, and then the time it takes for that sound to travel to the device and come, there's a whole physics about it. That's how it uses to detect the distance that um, it's seen. Now, so you need to the active pins are the trigger and the echo pins, and because we are using three of them, as you can see, I'm defining both the trigger and the echo for the soap sensor, the water sensor, and the paper sensor. And then we have the soap control pump, which is controlled on pin 8. And then we have the water pump control, which is on pin 9. And then the servo itself is controlled on pin 10. Then we have the buzzer. And then for the RGB LED, we're using two colors. We're using red and green, so they're on pin 12 and 13. So pretty much we used up all the digital IOs on the Arduino Uno. So it means that in future, if I want to add any extra things, I either have to use a Mega or use some uh, shift registers to add more I/O to it, but that's not um, part of the discussion for today, so we're going to keep it very simple. Now, then we're defining our servo here. That's one. And then we have constants we're using. So we're keeping the water on for 15 seconds, 3 seconds for the soap, another like 1.5, seconds, 1.5 seconds for the paper to roll. And then this is the distance in inches that I'm actually detecting. I'm actually saying that if you detect anything from 4 inches from the sensor, trigger the water, trigger the soap, and for the paper, 2 inches. So this is how I'm determining where the active regions are or distance are for the sensors. And these ones are just constant variables to help me. How long do you wait for? How long do I set up after the close angle for the servo motors and all that. Yeah. So that's everything in the definition of variables. And then in the setup, we're enabling the serial monitor because I wanted to see output from the serial monitor. And then we're setting the mode for the trigger pins. The trigger pins are all output because you're sending signals. And then the echoes are inputs. They take response from it. So that's how we set it. And then by default, we shut all the trigger pins. We don't send any signal by default. And then here, we're setting all the pumps also as output, but closing them or closing the gaps in the pumps. And then attaching the servo to the pin and then setting the close angle. So by default, the servo is stopped. And then these are the RGB settings, all are output. And then I have a simple, I think I shared this, I have a simple method here, set color, that sets it to green when it's available for use and red when it's being used or when the water or soap or paper is being dispensed. I have a little helper function here that gets the distance. So this is how you get the distance. You first of all make sure you are starting from no pulse being sent or no signal being sent. And then you wait for like 2 microseconds and then you open or send a signal to send just send a sonic wave and then wait for 10 microseconds and then now you shut that down and then open the echo pin to receive that pulse. Now once you received what I'm doing is that I'm using this calculation to convert it to inches and then I should have that in what I should have that the value in inches for me. The same thing is for the soap and then the paper. So and I have another helper function that beeps depending on the number of times I want and the delay I want it to have. So here that's what is happening. So when the loop starts, I try to get the distances for soap, water, and paper depending on which one is active. And then depending on the one that is active, I check if it is equivalent to the constant value I've set of 4 inches, 4 inches, or 2 inches. If that's the case for soap, water, and paper, you are going to do this. We're going to open the palms, we're going to open the soap or the water, or we're going to make the paper dispense. So this is on a high level quickly how I did it. If you want more, I have shared the link to my GitHub repo that has this code base and has the schematics. All right, so that is out of the way. And then, so to today's content. If you have any questions so far, hey, let me know. Send it in the chat. I will try as much as possible to answer that. Anyways, all right. So I'm smiling because there's something going on my social media feed that is quite funny. But hey, that's cool. We're gonna make this work. So I'm going to be posting. Thanks to Ishmael Lamte. I'm going to be posting the complete time lapse. Well, I won't say complete time lapse. I'm going to be posting a time lapse of how I was building it, the bits and pieces of it. I'm going to share that on YouTube. So I'll send the link once that's uploaded to see the processes I went through to make the build happen. And I'm just waiting patiently for my high torque servo motor to come. and then I can work on the bin as well. So let's get started. So for today's work, if you remember, we started with communication. We did device to cloud, and then we saw just a little bit of cloud to device. So today we're going to see, I'm going to go over how to do the cloud to device communication again, because, and this is why I'm doing this. And don't forget, we're still building a home monitoring system where we'll be sending data to the cloud, checking for response, and doing stuff like that. So it's vital we understand how to do the communication. And in the last two videos, in the last two episodes that was dedicated to the home environmental monitoring system, we're using Azure IoT hubs. We saw how to provision, how to connect to it. So we'll go back and visit that. That is in Python. But then I was supposed to have shown you with I think with the ESP, but we'll go back to the Raspberry Pi as a way of just recapping, and then I'll talk a little more about the twin, digital twin, and then in the next episode we'll now do for the, as I have here, we're going to do for the ESP32 board that I've already started. So this ESP32 is what will go into the bin. Because the bin is going to be internet enabled, I need a board that is internet enabled, and the ESP32 is a Wi-Fi and Bluetooth enabled board. So I mean, you could also use the ESP266, that's fine. But I'll go with the 32 because it gives me much stuff. Oh yeah, and sorry about this. I needed to also demystify this. So there is a group I find myself in. Let me actually bring this here. So they ask that. Now check this out. Okay, so yep. So that was something that someone asked me to demystify, and yes, I'm going to demystify it as always. This is the IoT show, and we try to demystify that. So I'm going to go to the bench just to explain this properly. So what you're seeing there is this light sensitive, you know, photoresistor, what how you wanna term that. Let me bring this here a bit so it'll be easier for us to see this. Yep, focus. Yep, there you go. That's it. Now this responds to light. Okay, it gives different values when it sees light and then when it doesn't see light. So technically, if there's no light, the resistance increases, and then if there's light, the resistance reduces. So that's how it's able to tell. And if you watch closely on that 404 not found Firefox page thing, where the cactus comes is a very dark spot, and therefore, if you realize they were pointing this, they pointed it at that section. All right, they pointed it at that section. So that means that anytime it sees that dark spot, it does something. Now, what the guy did in that video was that he used this SG90 servo, all right, here, as you can see. So what happens is anytime the signal it detects the darker portion, it sends a signal, just like the way we've been doing with our pumps and all that. It sends a signal to the board he's using, the Arduino board, to trigger the servo. So he's calculated the time and knows that if he waits for 2 seconds or 1 microsecond, he can use the servo to hit the keyboard this way. So beep. So anytime he sees the dark spot, send a signal and beep. So I promised the guys that I was going to build this just to demonstrate how it works. So that is coming. So I will show that. Okay. So let me actually take you back to the bench and then talk you through the process. So here we have a Raspberry Pi which is connected to the internet via this cable, and then if you look closely here, we have a DHT11 temperature humidity sensor here that is reading the temperature and humidity in my room right now. We've seen how to connect this. If you don't know how to, check out my previous episodes. I have all of them there. Now, we also added an LED here, all right, to the same board. Now, what's happening is that we're going to use cloud to device messaging to send a command from the cloud to turn this signal on, to turn this LED on. That is what we're talking about. And think about it. So I could bring the servo back. So here I could say the same thing. If I connect the servo onto this Raspberry Pi right now, like here, I can say that based on the temperature that is coming from our temperature and humidity sensor here, if the temperature is, extremely high, all right, use this servo to open the windows. That's one case. Or I can say that where is that? I can connect here. I can connect this relay. Okay, I can connect this relay to the same board and say that when the temperatures go high, use this relay to turn on a ceiling fan. That's another way. Or I can bring this here, this infrared sensor, which is found in your home remote, TV remote, air conditioning remote, all that. All I have to do is to know the hex code that turns an air conditioner on or off. And then when this starts to send, when the DHC sensor starts to send high temperatures in my room, what I can do is that I can do the cloud to device command and say that send this command to this IR blaster that will send a signal to my air conditioning to turn it on. And then if the temperatures also are too cold, the same thing as the DHC sensor is sending the temperature to the cloud, then the device to command the cloud to device command will come in and say, you know what, reduce the temperature. So these are different use cases that you can use cloud to device communication to do. So let's go ahead and take a look at this. So and remember, we did all this using Visual Studio Code and then the extension. And yes, I know you are wondering, let me just show you this. I'm going to flip to this scene. And as you can see, this is the Raspberry Pi. Yeah, this is a Raspberry Pi that is connected. So it's running the full, Raspbian OS on it. So, and I can open a folder here. There's a new folder. I think let's just open the folders. As you can see, I think our folder was dev, and then we have all these demos here. Okay, and just to prove that we are actually building, so I'm currently working on my Windows machine. All right, here, that's what I'm streaming from, but I'm using remote connection, or what you call the remote SSH from Visual Studio Code into this Raspberry Pi, and I'm programming, remotely. I don't have to connect to it and all that. So I'm going to show you that. So let's open our Visual Studio Code. And don't forget, if you have any questions about what I have shown, feel free to share this with me. Feel free to ask about it, and then we can get there. So let's go ahead and let's do a new window completely. Let's close this so we're not opening anything. And then if you have your, remote window stuff, it's going to be down here. I don't know if you can see that left bottom left. So it's actually a green button here. So I click on it, and then what happens? It's going to start to connect to the cloud. All right. Yeah, I click this, and then I'll say that I want to remote SSH to a host. And I think the IP address was, I think, 192.168 something something. Well, let's see. It should pop that up. Ba, ba, ba. Remote SSH into a host. Okay, activating extension. Okay, hurry up, hurry up, hurry up. Now this, because I've initially connected to, this Raspberry Pi, it will prompt me to do that. What's happening? Activating extensions. Yep, there you go. That's it. 192, that's 12. So I select it. And then it's going to, yeah, my network security thing is going to go off on me like 100 times. All right. So it's setting up the SSH to my Raspberry Pi host. which is on the same network as the computer I'm using. So I'm able to do the remote SSH quite easily. So setting that up, uh, tu- 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 tu. Hmm. Okay. So let's do this. I'm suspecting that. Let's see. Uh-oh. So looks like my LAN is disconnected. Yeah, that's why. So the my Raspberry Go there, as you can see, the network is back. So that was because for some reason my um the the network cable was not properly connected into the Raspberry Pi, so it didn't see it as being on the network. Yep. So I'm going to try this again. I'm going to go to remote connection, connect to a host. Yeah, and this is the host. That should try to connect again. And opening, setting up SSH, as you can see. And once we get into it, I can go in there, I can go in there and just start playing around, as in building directly onto the Raspberry Pi, which is just on my network somewhere. So Visual Studio Code is your go-to tool to do all this crazy stuff. And yeah, I need you to ask questions. Something that you're seeing, something that you're thinking about. What's that? What's that? What's that? More action. Let's see. Let's go back. Let me check this. I want to be sure that allows. So I'm having, all this my security things, trying to block all these things here. Let's see. So yeah, my my antivirus is okay. All right, my antivirus is like blocking a lot of the things on my okay. So let's see something. This is quite okay. So allow. Let me actually show you my deck so you see what's happening. So I have I have a Kaspersky antivirus on my machine. That's what I use, and it's actually, you know, messing around. It's quite protective of my of my computer. So let's try this again. Connect to host. That's it. 192. I think it's 12. I'm suspecting it's either maybe the IP has changed, but not. Let's see, because that actually discovered it. So hopefully, let's see. Let's see. Setting up SSH. Please set SSH up. Don't fail. I've allowed all the security um, access. Okay. So now I am more convinced we should go here. And let me try to do this. Let's see. Oh, I'm actually just a sec. Let me get the keyboard for my Pi. So I can type this command. Uh, and hopefully, okay. All right. So let's see. So if config here, I should see. Let's make this a little big. Yep. Let's make this a little big so we can. All right. Good one. Okay, so 192.168.100. So looks like it's now on 6. So it looks like our Raspberry Pi is now on port 6. So connect to the host and I'll do 192.168.100.6. Um, yeah, I'll just, yep, select the platform. This is a Linux platform. Are you sure you want to continue? Yes, I want to continue. The password is root. Uh, mm, 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 mm. No, this is not gonna work. Uh, let's cancel. And I explain why. The account that it's asking me for is not the account on the Pi. That's why I should have. So let's do this. Connect to host. I'm going to add a host. So as you can see, so I'm going to do root at 192.168.100.6, right? Let's see. Mm, 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 mm. Yeah, we can use this each configuration. And then, let's see. Let's connect again and see. Pa, 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 pam. Yep, this is Linux. And then, yep, now enter password for root. I enter my super expensive password. And then, yep, ask me to confirm. And then, this should now, huh. Mm, 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 mm. Let's see. Hmm. What is it saying? Gods of Demo Day released by machine. Okay, let's see. Let me try this again. So 100.6. It's a Linux machine. There you go. There you go. Pum. Root. If this doesn't connect, okay. Let me retry this. Let's close. I'm actually going to let's try this. Open a configuration file. I have this. I'm going to open the previous configuration that we saved, and then I'll just make changes to it and see if that works. Okay, let's see. Let's see. Open. Mm, open the configuration file. Let's do this. Let's go to open configuration file. And this is program data SSH. So let's do program data. Now I can't spell program. Oh, really? 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 Let's see. Okay, that's opened it here. And let's do SSH. Let's look for SSH. Yep, that's SSH. This looks empty. Okay, let's try this again. Open configuration file. Interesting. Interesting. Okay, let's try this. So that's because it can't find that. So that's the host. Oh yeah, so this is it. Yeah, user. Okay, pi. Let's save this. Let's close that. So I think my mistake was using a different username. So let's connect. Let's use the 6 again. That should pick the user pi. Yeah, it's a Linux machine. Yep, and then let's try our super sexy password. Yeah, there we go. Yeah, my bad. So I was actually using a totally different user for that. So forgive me for that, but yep. You selected Linux as a remote platform. This will be stored in the settings. Yeah, store it. Okay, so now if I go to open folder, now check this out. We are working in the dev folder. All right. So show local. All right. Let's open it. And then where's the dev? There you go. And then open. Yep. This is the dev folder. It will ask me to enter the password again as a safety measure. I put in my super sensitive password. Yay! And we're good to go. So now, just to prove to you that we're working on the on the Raspberry Pi, I'm going to flip again to the Pi and take a close look at this. I think I can close this now. And then let's open the folders and look at dev. I hope this is a bit clearer. Now you can see dev has the PyCache, the .m. Okay, we didn't push the .m. So it has the the PyCache. It has the demo, the DHT11 LED. It has all this here, which we are seeing here in our Visual Studio Code. So to prove that this is what's being sent or is being created directly on the Pi, I'm going to add another file, and I'll just call it confirm confirm.py. Save this, and I'm going to flip here and check this out. This is it. There's confirm.py here. So that tells you that we're working remotely, in it. So cool. That's all we're worried about now. Our So this is I think it's a DHT demo. So here this is the code. So this is what we have currently running on the Raspberry Pi. We have a couple of libraries from Python. We have our DHT sensor on 4, and then we have the LED on 18. Now, so currently when the app loads, it's connecting to the Azure IoT Hub, and then we are setting the connection string, and then we are just reading the temperature data. Now, I did something here, so it collects the temperature data. But one thing I did was, if you're using IoT hubs, you have a limit. Okay, you have a limit of the number of messages you can send in a month, especially if you're using the free tier. Now, if you're saying you are pulling temperature data like every 5 minutes, 5 seconds or something, you're going to burn through that. So a technique I use, which I learned from I've forgotten the guy's name on the internet, but it's another technique, was to check the previous temperature. So anytime a temperature reading is made, okay, we store that temperature reading, and then we compare it to the previous one. If it's different, then we send it to the cloud. If it's not different, we leave it. The assumption is that the cloud already has an updated, temperature. So until something changes locally, you don't push that to the cloud. And then, so that is sent to Azure IoT Hubs. Now, from within IoT Hubs, as we're going to see fully in next episode, we can send commands. So currently, to do this, I'm just going to run this. So Python 3, and this is dht11.py. So this should run the Python code, and this should now push. So as you can see, the application is running. This is it. So first of all, sending data to IoT Hub, because the initial temperature was 00. Now temperature is 24. So now look at this. It's sending the temperature. It only sent it once. It only sent the temperature once. Now, I wish I could have a chalk library in Python so that I could distinguish if it is, red, green, so you can see the difference. But as you can see, it's not centered again because the temperature is still 24 degrees. So this saves me a lot of, message count. However, you see that for any time that loop is happening, it's also receiving the digital twin from Azure IoT Hubs. So the digital twin is just like a digital representation of this Raspberry Pi. Imagine it could be a digital representation of your fridge. It could be a digital representation of your car. It could be a digital representation of anything that you want to have a digital version of for you to maybe control, update, monitor, and protect. So that's why it's called digital twin. Now, I can now manipulate the digital twin or control the digital twin to have a desired state I want the actual device to be in. Let's take an example. Let's say this can be used in even in vehicles, all right, where now we are worried about overspeeding on our roads. So we can put in something, we can put some IoT sensors, or we can actually put some devices in the car that allow us to control the acceleration of the vehicle. And then based on digital twins and even Azure Spatial Anchors, we can say that if you're driving on the Accra Tema motorway, all right, we make sure that the car will never go beyond 100 kilometers or 80 kilometers. That is because we have a digital twin of the car, and it has a desired state that at any time you are on the motorway, your desired speed or the maximum speed is what? Is 100. So it would never allow the car to go beyond that speed limit. These are some of the innovations you can do with digital twin. So right now, as you can see, it's just sending. Right now, it's still 24, so nothing will be sent. Now, if I take you to the bench, you realize that there is an LED here at this point. It's not on. All right, that is because nothing is done. However, let's see how we can use Azure IoT Hubs to instruct this particular to send a command from cloud to it. So which means that all this data that is going to IoT Hub, I can act on the data. Exactly. I can act on the data and say that, okay, welcome, Kwame Frimpong, welcome. Nice to have you on the show. So I can say that anytime the temperature goes beyond 30, okay, turn on just an indicator. Now this is just, I'm using the LED as an example. I mentioned that that could be a servo, that could be a relay, that could be a, where is that? It's been a long time since I pulled this out. I think it deserves some love on today's show. So I'm going to pull this out. Well, like it can be an alarm. It can be sent to a smartwatch. Okay, anything can be done. So let me show you how this is happening. So let's go back here. Actually, I have the 4 state here. Cool. I did this for you guys. You can see me here. You can see the code on the top left. So what I'm going to do is that I'm going to zoom this in here. Yeah, I'm going to zoom this in really big so you can see what's happening there. We have the board here, and then we have my screen here as well. Okay, so let's go into how do you call that? Let me minimize this and let me bring another browser here, and let's go to portal.azure.com. So we're going to connect to Azure IoT Hubs, and then we're going to send the command from this time. We're going to send the command from the IoT Hub. Okay. However, I could use Power Apps, which I'm going to show you that when the bin comes. When I'm done with a smart bin, I'm going to actually use Power Apps to get data from the sensor that tells me the level. So I'll mark 3 levels: when it's low, when it's mid, and when it's full. So when it's full, that data will be sent to IoT Hubs, and that will be pushed to my Power BI desktop. So, or Power BI report or dashboard. So I can see the state of all the bins. So think about this. If we have smart bins all over the city, all right, we can tell which bins are full at what point in time. And this can be correlated with the waste tracks, and actually even use Azure like spatial anchors and maps to tell it the optimal path to take to go dispose of all this waste. So think about it. Just be smart. All right. I think we use Outlook. I am not sure, but we're just going to check this out. Let's go. Okay. Hopefully I remember my password. I have a lot of passwords. It's hard to keep up with it. So as you can see now, um, we pretty much have nothing going on here. And yeah, yes, I'll show that. Someone is asking, can I show how to use the infrared sensor to control as a remote control? Yes, I'll show you how to do that in subsequent videos, or maybe I might just write a blog post. Guys, to be very honest, sometimes it's hard to keep up with, writing blog posts and doing this and doing that. But trust me, I'll find time to, to put this together for you guys. All right, so this was IoT Tuesday. This is our IoT Hub. I'm going to open it. Let's first go to, let's go here fully first. All right, let's go here fully, and then once we are done, I'll bring back. Okay, so this is our IoT hub, and then if I go to devices, beep, 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 on the left, where are you? IoT devices. There we go. You can see our Raspberry Pi is listed. Devices loading, 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 loading. Here we go. This is our Raspberry Pi right here. All right. Now, I have stated that when you open the Raspberry Pi, so there is a device. Now, if you look closely at the top, I'm going to go through it. We have the message to device. So here, I can send the message to the device using this button here. But there's an API for this. So instead of clicking this button, I can use power ups. So I can have a very big button in power ups. When I push this, that sends the message to the device. So I can now control my home automation devices from power ups. Now I can use this also from Power Automate to say that, now listen closely, to say that anytime the temperature value comes in and is above a setting limit, use Power Automate to start an automation workflow to call maybe a direct method. That's the next thing. Now for direct methods, I can actually add setting functions on the Raspberry Pi. All right, and then I can use this direct method option to call those methods. So this could be turn on AC, turn on fan, rotate servo 90 degrees, whatever that is. All right, and then here, this is the digital twin. This is a digital twin for our current Raspberry Pi. All right, so this is it. I'll just go here and say digital twin. And then this is a digital twin for the Raspberry Pi. It has a lot of properties. Now, the properties you have to be worried, or not worried, but you need to take into consideration, or you want to check out, is this one. It has something called the desired, properties called desired. So everything in this desired, as you can see from here, is what you perceive your device to be in. So if this were a company car, we want all our company cars to be running at 80 kilometers per hour when on the motorway. We want all our cars to have a minimum fuel level of, let's say, 25% in the tank. So anytime your car's fuel level is going less than 25%, boom, you want something to happen. You want it to trigger something. You want it to send a message to the driver. You need to go refuel. You need to tell the filling station that, oh, you need to look out. Okay, you can look up all the filling stations in close proximity. So I mean, let's pause and assess this. If you implement things like this, let's say you're a company and you have a fleet of cars, all right? You put this sensor in your car, and this is IoT. The supposed cause for the supposed 5G calls for COVID-19. This is how it's helping us. And anyway, I decided I wasn't going to go there. Sorry, I'm not going to go there. So let me stick to the theory, the idea. So assuming you're a company and you have digital twins for all your cars, okay, and you have a sensor that reads a lot of these things, your fuel gauge, your fuel level, everything in the car. You can set a desired state here and say, I always want my car to have 30% fuel. The least it can go is 30. It can't go beyond 30%. So as you are driving AI smart car, it calculates the distance you are traveling and tells you that, okay, you're going to, let's say, Kumasi, but looking at the miles and the miles per gallon usage, and then the fact that your desired state is 30%, you have to stop at, we've identified filling stations 1, 2, and 3 or this particular filling station, when you get to this filling station, you need to refuel, else you go below your 30 what percent. It could be that you can even say that if the fuel goes below 30%, send a signal and stop the car. Whatever you want to do. So this is what I'm interested in. Now, in the design properties here, we put LED. As of now, it's 0. And I'll show you the code in the Raspberry Pi that's handling this. So we're saying that if the desired state changes to 1, which is a command we are sending to the device, turn on the LED. So now I'm going to flip to the full screen. So keep an eye on this section here where the LED is showing. So I'm going to change, as you can see, let me make this a bit bigger. So I'm going to change the desired state to 1. As you can see, I've changed it to 1. I'm going to hit save at the top, and then keep an eye here. Now check this out. There you go. The light came on. Can you see it? Maybe I need to cover it for you to see. There you go. See? You can see a yellow light there. Let me go ahead and try to change the desired state again. I need to bring this here so I can change the desired state. So I'm going to change the desired state again. I'm going to change it to 0. And then I'm going to do a save. And now look, in a couple of minutes, look on the top right. Yeah, the light is going. I don't see any yellow light again. All right, I'm going to do it one more time. Make it, change it again here. Let's change the desired state here. 1. And then let's go up. So we are sending a command or an instruction to the desired state, and there you go. It's changed to what? To yellow. So this is how you can send cloud to device messages. So this is how you can have a fleet of devices and manage them from a central point to ensure that did you see it, Kwame? Did you see it when I covered it? So I know because of my light, because of this light, it's quite hard to see it. Hold on, let's see this. Um, Let me see how I can. Okay, so if I do it this way, I think I'll do it this way so that it reflects into my camera, so you can see it properly. Okay, sorry about that. Now, good. So now you can see the beam of the yellow in the light. So let me go back to the desired state here, and then let me change it back to. Let's go up here. Yep. So I'm going to change it back to 0, and then we'll save this. So I'm sending a 0 to the device, and check that out. Within a few seconds, can you see the light is gone off now? So now it's gone. If I go back to desired state and I say now I want the desired state to be 1 because things have cooled down. The temperature in the room has cooled down. So, so now let's save this. Let's save the desired state. This is a configuration, and check this out. The light will come back after a few. There you go. All right. So desired state is used to keep your devices in the preferred running condition. So let's corporate air conditioning in an office. You want all the air conditions to be running at, let's say, 20 degrees all the time. All right. Or you can also have another model, an AI model that calculates the weather conditions, and based on the weather conditions, it can modify the desired state of your devices. And this desired state is pushed to your device. So anytime the desired state comes to your device, the device is going to be in the preferred, state. So that is what we have for today. I hope that was very informative. I hope that was captivating. If you have any questions concerning IoT hubs, device twins, all this, let me know in the comment here. And yes, if you were following me on social media and all that, you would have heard in the news, or you would have seen that I have been nominated. Not nominated. I received my Microsoft MVP award last week. That makes me the first Ghanaian MVP on Azure. So interesting stuff going there. Yep, Scribble, yes, welcome Scribble. That was neat. Thank you very much. If you like the show, please subscribe. There's more to come. So let me go back just one step here, just to show you. So Next week, I'll be talking about message to device and direct method. Yeah, yes, yes, Rimpo. Yeah, 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 yeah. Yep, yep, that was it. I was very excited. I'll share that. Actually, I'll share that on my social media tweet. I'm just waiting for the award and I'll write an article about that and do a video about that because it's very emotional. Yep, so so next week I'll be talking about message to device and then direct method. All right. And then if there's time, we can explore add modular identity or something to it. So if this was interesting enough, don't forget to make a deal with me every Friday, sorry, every Tuesday for IoT, Friday for demystifying anything technology, and Sunday for Power Series. If you want to talk about tech, if you want to talk about IoT, AI, anything technology interesting in our today's world, just holla at me. Holla at me and I'll make it happen. Well, this has been yours truly, Samuel Adjani, bringing you another exciting episode of the IoT Tuesday show. Yes, I know. I know I owe you OBS lessons as someone. Let's see. Let's chat after the show. I'll hook you up. I'll sort you out on that. All right. So until I come your way again next week, stay safe. Don't listen to any rubbish. Be discerning. Don't have the fear of posting late or fear of sharing late. Don't be led by any stupidity or any idiocracy. Discern. When you get information, discern. Talk to people, professionals, not just anybody. Don't be quick to share. And let's make this world a better place. If you have any ideas, please share. Let's work together and fight and beat this thing. Until then, I'm out.